So in this video, we're going to look at Coulomb's law. And Coulomb's law looks at the force that is found between two charges, whether it's attractive or repulsive. So first, let's talk about the concept behind Coulomb's law. So we have a picture here of a hydrogen atom. A hydrogen atom has one proton and one neutron, or one electron. And so we're supposed to label the proton with a plus and electron with a minus. Protons are found in the nucleus, and so this is our proton, so plus. Our electron is in the cloud around the nucleus, so this is our electron. The electrical interaction between the nucleus and the electron is, well, it's plus and minus, so opposites attract. And so here is Coulomb's law. F equals K Q1 Q2 over D squared. This equation should look really, really familiar. It should look a lot like this one. Fg equals G M1 M2 over D squared. And it's because the principle behind electrical forces is the same as the principle behind gravitational forces. Here, we're looking at the interaction between two charges at a certain distance. And in gravity, we were looking at the interaction between two masses and the distance between them. So the larger the masses, the more force. The larger the distance, the smaller the force. Here's the same idea, except instead of mass, we talk about charge. The more charge you have, the more of a force there is between the charges. And the larger the distance is between the charges, the smaller the force is. So now let's erase that. You don't need to worry about that one anymore. So if the charge of either the nucleus or the electron were greater, so the greater charge, then what would happen to the force? Well, if a charge increases, then the force will also increase. So it'll be greater. And if the distance were greater, so if these were further apart, then the denominator would be getting larger, so the force would be less. If the distance between the nucleus and electron were doubled, how would the force be different? Well, here we go. It says doubled. And so these problems are our favorite types of problems, factor problems. So as a review, how we do factor problems. Number one, mark out everything that doesn't change. And number two is put in the change. So here in our equation, we're looking at a distance change. So why don't I use a different color here? So the distance is doubled, and we want to know how the force will change. So the two things involved are distance and force. So circle force, circle distance. Everything else gets marked out. And so the change in the force is equal to the change in the distance squared, but since it's on the bottom, we have to keep it on the bottom. So 1 over d squared. So now, how is the distance changing? The distance is doubled. So number 2 says to put in the change. So F equals 1 over double, which is 2, squared. So it'll be 1/4 of the force. If you double the distance, you get 1/4 the force. So 1/4 as much. So now let's look at a few more of these factor type problems. So the charge on one of the particles, so charge doubled, how does force change? K Q1 Q2 over D squared. Okay, so now force and charge are changing. So one force, one Q. Everything else goes away. So the change in force is equal to the change in charge, which is doubled. So if you double a charge, you double the force. So now, if both charges change, how will the force change? So both charges are going to double. So K Q1 Q2 over D squared. So now force is changing, and both charges are changing. So F equals Q1 Q2, which is 2 times 2. So force will quadruple. If instead the distance is halved, how will the force change? Okay, so F equals K Q1 Q2 over D squared. So distance and force. Force, distance, nothing else changes. And so again, we get that F equals 1 over D squared. And so now we have 1 over 1/2 squared. And if you put that in your calculator, you get 4. So if the distance halves, the force will quadruple. All right, so distance is halved, and the charge of both particles double force. So here we go, F equals K Q1 Q2 over D squared. And so force changes, both charges change, and distance changes. So the only thing that doesn't is our constant. So F equals Q1 Q2 over D squared. So let's see, charges double, 2 times 2, and distance is halved. So 1/2 squared. So put that in the calculator. You get 2 times 2, which is 4. And then 1/2 squared is another 4, which we found here. So it'll be 16 times as great. 1/2, 2 times 2 over 1/2 squared gives you 16. So there's your concept. How do these things change and what happens to the force? So if you increase charge, it increases force. If you increase distance, it decreases force. So direct with charge, inverse with distance. So here's the official equation. So our equation is here. This is the equation. K Q1 Q2 over D squared. K is just a constant. Just like our big G was just a constant. This is a number. This is a unit. So this is just a number with a unit. So it's like 9.8, just like we did with little g. So F is force, K is Coulomb's constant, Q1 and 2 are your charges, and D is your distance. All right, let's do some examples. So example 1, so this is plug and chug. The way we know it's plug and chug, unit, unit, unit. If every number given to you has a unit, it's plug and chug. Plug and chug. If you're given changes, then it's a factor. All right, so F equals K, which is 9 times 10 to the 9th. Shorthand that, calculator form, 9e9. Q1, so here we go, charge 1, 6e negative 6 times charge 2, which is 3e negative 6, all over distance, which is measured in meters, 0.030, squared. Don't forget to square your distance. So if you literally put this in the calculator exactly like this, 99 times 6e negative 6 times 3e negative 6 divided by 0.03 squared, you will get 180 newtons. Force measured in newtons. All right, second example. What is the second charge if a 1 times 10 to the negative 7 Coulomb charge experiences a force of 100 newtons at a distance of 0.01 meters? So we're looking for the second charge. So we're looking for Q2. This is also a charge. So this is Q1. Force of 100 newtons makes this F, and distance is D. So 100 equals K, which is 9E9. You cannot forget that constant. Times 1E negative 7 times Q2 over 0.01 squared. So there are multiple ways that you can solve this. One is you can go ahead and move this over, then you can move this one over, then you can move this one over, but use the steps in algebra that work best for you. The other way you can do it is 99 times this divided by that squared. Why don't we go step by step, pulling everything over one at a time. So first it's this times 99. So we're going to divide both sides by 99. And so we get 100 over 9E9 equals 1E negative 7 times Q2, not Q squared, over 0.01 squared. So now let's get rid of the denominator. So it's this squared, so we're going to times 0.01 squared on both sides. Okay, so that cancels this out. So our next step is that we have 0.01 squared times 100 divided by 9E9. And that is equal to 1E negative 7 times Q2. And so our last step is to divide by 1E negative 7. So divide by 1E negative 7. And we're left with Q2. If we do all of this math together, we get 1.11 E negative 5. And charge, Q, is measured in coulombs. All right, last example. What is the charge on two equally charged objects that experience a force of 200 newtons? Okay, so that's our force at a distance of 0.05 meters, which is our D. So we have two equally charged objects. So that's Q1 and Q2. So here we go. 200 equals 9E9 times Q1, Q2 over 0.05 squared. So again, we're going to start with all of our steps. First thing we're going to do is divide by 99. And so we have 200 over 9E9 equals Q1, Q2 over 0.05 squared. And then we want to get rid of this 0.05, so we're going to multiply by 0.05 squared on both sides. There we go. So here we go. Q1, Q2 equals 200 times 0.05 squared over 9e. So why don't we find this value first? So 200 times 0.05 squared divided by 9e9 gives us Q1, Q2 equals 5.556, so it's 5 repeating, E negative 11. Now here's a dilemma. We have two unknowns. But they're equal, which means Q1 equals Q2. So since these are equal, we could just drop the 1 and 2, because it doesn't matter if we're making a Q1, Q2. And so we have Q times Q, which gives you Q squared. So Q squared equals 5.556 E negative 11. Now can you solve for Q? To find Q, square root both sides. And so you get a final Q of 7.45 E negative 6, and charge is measured in coulombs. So Q1 and Q2 will both have this exact same charge.